Okay, this lesson is on polar coordinates and basic polar equations. The first thing that we want to know is that the points when we're in polar form are of the form r and theta. R is the radius that it is out from the center. Theta is the angle that it's at. So if you'll look at some of the graphs that I have for us to use, we have a center, and then we have radiuses because we have lots of circles here, and then we have the angles listed. Imagine looking down at a globe from the North Pole or looking up from the South Pole. You would see the latitude and longitude lines looking kind of like this, and so you can kind of think of it like that. Or you can just think of it as being on an X and Y axis, and it's just a different way to locate a particular point. But again, the first number is the radius, the second number is an angle. I put a star here because if the radius is negative, because sometimes they'll give us a negative radius, which doesn't really make sense in our minds, what that means is that we're going to flip to the other side. It's like a reflection across the center when that happens, and I'll show you some examples of that in just a moment. Alright, so first thing we're going to do is just graph some points, and I recommend again using a colored something so that it shows up well when you're writing on these graphs. So 2 pi over 3. It doesn't matter which one you go to first. 2 means it's on the second radius out, so the second circle, the radius is 2. Pi over 3 means it's at the angle pi over 3. So this is just a point that is at pi over 3 and radius of 2. So about right here. So we just plot that point. Mine tend to disappear on here, so I'll try to draw it again. Hopefully it'll stay. Okay, example 2 would mean, the 3 would mean we're on the third circle out, and the angle would be negative pi over 6. So these are labeled all going in the positive direction, so you're going to have to think about where negative pi over 6 would be. And we've done lots of trig in this class, so you know if you go backwards pi over 6, you would land at 11 pi over 6, what we see here. And that's the goal. The negative pi over 6 is the same location as 11 pi over 6. And we're on the third circle out. So 1, 2, 3, and at 11 pi over 6, we're going to put a point. Now we're going to go to a couple that have that negative radius I was talking about. We'll be on that first circle, radius 1. And we're going to go to 3 pi over 4. So circle radius 1, go to 3 pi over 4, which is right here. And instead of putting the point in this location, you mirror image it across the origin to the one opposite of that. And that would be the 7 pi over 4 line. And you put that point on the first circle and the 7 pi over 4. Because of that negative. So the negative is mirror image across the origin. And so why don't you pause now and try number 4. So for number 4, you had to think about a negative 2 pi over 3, so you were going backwards. And negative 1 pi over 3 would be here, negative 2 pi over 3 would be here. It's the same location as 4 pi over 3. And you're on the second radius, so right here. But instead of that point, I want to flip across the origin 0, 0 and put it on pi over 3 and radius of 2. And the reason I'm flipping again is because of that negative in front of the radius, the negative 2. Okay, now for example 5, I want you to plot each one of these points on the 4 graphs that I have provided for you. So take a moment, pause, and plot all 4 of these points. Okay, if you have plotted all 4 of them correctly, you would notice that they all end up in the same place. And I tried to use a different color to see if it would stay. all of them, basically, if you were going straight forward, would end up at 1 and 5 pi over 3. So the first one, you went backwards to get there with the angle, but you were still with a radius of positive 1. On the third and the fourth ones, you had negative radiuses, so you ended up flipping from the opposite side. And you can either get there by going to 2 pi over 3 or going backwards, negative 4 pi over 3, puts you in the same spot, and then you flip and you end up on that same 1 and 5 pi over 3 place. What that should tell you is technically there's infinitely many points that can get us to the same location. We're going to be working with the first basic 4 that you can come up with. Notice these first 2 have a positive radius, the second 2 have a negative radius, and then you would go backwards to get to the angle, go forwards to get to the angle, and forwards to get the angle, and backwards to get the angle. So there's a pattern to it, getting those points that all end up in the same place. So let's take that into consideration and find all the points, or 4 points, that would give us this location right here. Now, this is on the second circle out. So I can already tell you that since it's a radius of 2, my points are, I'm going to have 2 points with a radius of 2 and 2 points with a radius of negative 2 if I'm following that same pattern from the previous example. And then you have to think about the angle. Well, to get to this angle, if you go, the normal way, starting at 0 and going around counterclockwise, you get to pi. So and the easiest way to get there, so we have the point 2 pi. So our second point, we would get there by starting at 0 but going backwards. So this would be negative pi. Now, when you have a negative radius, you are flipping, so I have to think about not the point I'm looking at, but what it would have flipped from. So this point would have flipped from the 0 angle, or you could think of it as 2 pi, but it would have flipped from this point right here. So how can I get to that point? Well, I can get to it from just calling it 0, or I can call it 2 pi. If I think about going backwards, I could call it negative 2 pi. So this one actually has several options there, and they would all be correct. When I ask you to find 4 points, I just want 4 different points. I'm giving you a method here, but as long as the 4 points are different and but all represent the same location, then you have completed what I'm asking you to complete. So let's practice one that isn't quite so interesting as 0 pi, 2 pi kind of things. And let's do this one. So this location, the first thing I notice is it's on the third circle out. So I'm going to go ahead and write down radius 3, radius 3, radius negative 3, radius negative 3. And again, this is just ensuring that those are giving me different points. And the first 2, I'm just going to go in the positive direction and get to the angle, and then in the negative direction and get to the angle. So if I start at 0 and I go in the positive direction, I land at 11 pi over 6 as you see it. So 3 and 11 pi over 6. If I start at 0 and I go backwards, I only have to go backwards 1 pi over 6 to get to that point. So negative pi over 6. And that to me is the 2 easy ones to get. When you get to the 2 with the negative radius, then you got to remember they flipped from somewhere. Where are they flipping from? They are flipping from the 5 pi over 6 line, the third circle out. So they're flipping from this point right here. And so I'm going to think of how to get to that in the positive direction, and then how to get to that in the negative direction. So in the positive direction to get to that point, we just went to 5 pi over 6. In the negative direction to get to that point, you had to go backward 7 pi over 6. And this is where counting those radians is going to come in to play. So negative 7 pi over 6 there. Now we're going to get into our basic polar equations. And these are the most basic. We're going to get into some more challenging ones in our next lesson. The first kind is when you just have r equals a number. That means it's a circle with that radius. So if r equals 5, it's just the circle at 5, the radius of 5. If theta equals a number, it is a line at that angle, and it will continue in both directions, not just starting at 0. So, for example, number 8 is asking me to sketch the graph of theta equals pi over 3. So I'm going to use the computer here, help me out. Theta pi over 3 is right here. I'm going to draw the line that goes all the way through pi over 3 and through the other side. So this entire line here. And let's make that something that we can all see. So it's that entire line. So for example 9, you do the same thing, you're just at 3 pi over 4. So 3 pi over 4 is right here. I do the line through 3 pi over 4, continuing through the other side, which would be at 7 pi over 4 and going on. And so that is how I graph those simple equations. Now, when we're talking a radius 2, radius 4, we're talking about a circle. The graph will be a circle. All the points at that radius of 2 and all the points at that radius of 4. And so, again, these are easy. We just want to draw that circle in. So I'm going to try to do this. You probably have a better job on your paper. And so there is my circle at radius 2. And obviously you'll still see the graph, but using the computer it kind of takes some of that away. And so then try doing the radius of 4. Pause and do the radius of 4. And so your graph is going to look something like this, but you'll obviously still be able to see the grid underneath. So those to me are very basic and very easy and things that everybody should be getting correct. Alright, the last thing that we're going to do is some basic conversions. And today we're just going to convert from polar coordinates to rectangular coordinates. Rectangular coordinates are what we use every day. And so like what you think of as normal x's and y's. You're going to need to know and memorize these two relationships. X equals r cosine theta and y equals r sine theta. You'll notice it's similar to what we had with the unit circle because on the unit circle our x value was cosine, our y value was sine. All you have to do is remember to multiply by the radius. And so if I want to convert this polar coordinate with a radius of 2 and a theta of pi, I just need to plug in. My x value is going to be 2 times the cosine of pi. My y value is going to be 2 times the sine of pi, and that's where knowing your unit circle comes into play. So since at my unit circle at pi, the point is -1, 0, my cosine is -1. So x is 2 times -1, which is -2. Then sine of pi from my unit circle is 0. So if I plug 0 in, anything times 0 is 0, so my y value is 0. So the point that I'm looking for is -2, 0. That is the rectangular point that will be the same location as the point 2 pi. So you may want to pause now and try 13 on your own. Okay, so again, you would set it up. X equals your radius times your cosine of theta, so square root of 3 cosine pi over 6. Your y is your radius times your sine of the angle, so square root of 3 times the sine of pi over 6. And then you have to think about your unit circle. What is the point at pi over 6? And that point is the square root of 3 over 2, 1/2. So for the cosine, I'm going to plug in the square root of 3 over 2. And that means on top, you have to think of this like square root of 3 over 1, and you just multiply straight across. So on top, I have the square root of 3 times the square root of 3, which is just 3. On the bottom, I have 1 times 2, which is 2. For my y value, the sine is 1/2, because that's my y value of my point. And I can, again, think of that square root of 3 of being over 1. And I go straight across, and I get square root of 3 over 2 as that y value. So this point is 3 over 2, square root 3 over 2. And that is the rectangular point that matches this polar point. And that concludes this lesson.